Acetophenone. So structure of acetophenone is benzene C double bond O CH3. Acetophenone. Acetophenone treated with Grignard reagent PHMgBr. It is a Grignard reagent and pH minus is nucleophile, and we know that aldehyde ketones undergo nucleophilic addition. Therefore corresponding product is like this. So it is a added nucleophile. Now it react with the dilute H plus. O minus take the proton from the H plus, and finally it gives corresponding tertiary alcohol. Tertiary alcohol. Now it is treated with HI, hydrogen iodide. So it is a tertiary alcohol. So tertiary alcohol reacted with HI. So HI means H plus and I minus. Therefore primary SN2 type of reaction, secondary and tertiary SN1 type of reaction. Primary SN2 type of reaction, secondary and tertiary SN1 type of reaction. Therefore since it is a tertiary, so it follows SN1 mechanism, and initially it forms stable carbocation, and here ring expansion migration not possible. Now it reacts with corresponding I minus, and finally it gives corresponding tertiary iodide. Tertiary iodide. So here two mechanisms are involved. First one is nucleophilic addition, second one is nucleophilic substitution. Alcohol POCl3 pyridine. When alcohol treated with the POCl3 and pyridine through E2 mechanism, dehydration takes place. Through E2 mechanism, dehydration. That means the product is alkene. The product is alkene. For example, here CH3CH2OH. For example, if it is treated with the POCl3, lone pair attack on the phosphorus, Cl will leave, and finally it gives corresponding CH3, CH2, O, P double bond O, Cl, Cl. Now it is a leaving group, alpha and beta. Now pyridine act as a base. So through E2 mechanism, base remove the proton, leaving group will leave. Finally it gives corresponding alkene. So this is the dehydration mechanism, and E2 mechanism is anti-elimination. Therefore in the given question also it is above the plane, it is below the plane. Now it is treated with the POCl3 and pyridine. So definitely E2 mechanism possible. Alpha leaving group, beta proton. But here this proton is above the plane. So at this position no elimination. But here one proton is below the plane, one proton is above the plane. So whatever we have explained here, so through that mechanism, here dehydration takes place and corresponding product is alkene. Alcohol POCl3 pyridine through E2 mechanism, dehydration takes place. To this compound we are adding H plus H2O. When we add H plus, alkene react with H plus, it is electrophilic addition. So form stable C plus based on number of hyperconjugation. It is a stable carbocation position. Now it reacts with the corresponding water molecule. Finally the product is water can attack on the C plus above the plane as well as from the below the plane. The reactant has alcohol and ether. So when we add SOCl2 and pyridine, SOCl2 and pyridine, we know that when alcohol treated with SOCl2 and pyridine, SOCl2 and pyridine, through SN2 mechanism, alkyl chloride will be formed. Through SN2 mechanism, alkyl chloride will be formed. So here also it is an alcohol, primary alcohol react with SOCl2 in the presence of pyridine. It also give corresponding alkyl chloride. Now this alkyl chloride treated with a magnesium. So magnesium is a metal. So ether won't react with the metals. Ether won't react with metal, but alkyl chloride react with metal. We know that when Rx treated with the magnesium, it gives corresponding R minus Mgx plus. Therefore here it forms corresponding Grignard reagent. It forms corresponding Grignard reagent. Now it is treated with corresponding epoxide, and it is a strong nucleophile. Strong nucleophile react with epoxide. It follows SN2 mechanism. That means primary greater than secondary greater than tertiary. Therefore nucleophile attack at primary carbon, ring opening takes place. Ring opening takes place. So this is our added nucleophile. It is the nucleophile. Now after acidification, finally it gives corresponding alcohol. So it is a nucleophile. So through SN2 mechanism it is added. So first one is SN2 reaction, second one is Grignard formation, and third one is again SN2 reaction. Alkene treated with B2H6. Alkene treated with the B2H6. This reaction is known as hydroboration. This reaction is known as hydroboration. So we know that in the hydroboration, more sterically hindered carbon will be connected, hydrogen, and less sterically hindered carbon, boron, will be attached. It is a hydroboration. Now it is treated with the H2O2 OH minus. So this is oxidation. So here simply in place of boron, we should write simply OH group. In place of boron, we should write simply OH group. Now it is treated with the tosyl chloride. Tosyl chloride is para-toluene sulfonyl chloride. So here what happens? Lone pair attack on the tosyl group, Cl will leave. So lone pair attack on the sulfur, Cl will leave. So this is entire group is tosyl group. So simply we can write corresponding OTS. And OTS is very good leaving group. And we know that OTS is good leaving group than I minus, than Br minus, than Cl minus. When compared to halides, OTS sulfonates are good leaving groups. Now it is treated with the tertiary butoxide, sodium tertiary butoxide, and tertiary butanol. So it is a bulky base, strong base and bulky base, and it is a very good leaving group, Therefore here E2 elimination takes place. Alpha, beta, beta. Therefore more stable alkene and less stable alkene both are formed. But since it is a bulky base, most acidic proton, less stable alkene will be the major product, because bulky base can approach this carbon easily, less sterically hindered carbon easily. It can take the proton easily, but bulky base cannot take the proton here that much easily. That's why it is minor product and it is major product. So that's why it is a major product. So here the first reaction is hydroboration oxidation, second reaction is nucleophilic substitution, and third reaction is elimination E2. So the first compound is alcohol and ether. So when this reactant is heated in the presence of H plus, so we expect here alcohol dehydration. So lone pair attract the proton and it forms corresponding OH2 plus. Even though it is primary, in case of dehydration, C plus will form. In the case of dehydration, C plus will form. Now corresponding ring expansion to get corresponding stable intermediate. And this can be written as 6-membered ring, oxygen positive. So because of octet, it is a stable carbocation. Now it loses proton and finally it gives corresponding product like this. So here it is a first reaction. The overall reaction is simply dehydration. Now it is treated with H plus and methanol. When H plus is added, alkene react with H plus. Alkene react with H plus, give stable C plus. Now the stable C plus react with the nucleophile methanol, and finally it gives corresponding ether like this. So this is acetal. It is acetal. So here the first reaction is dehydration. First reaction is dehydration. Second reaction is electrophilic addition, because alkene react with H plus followed by nucleophile. Electrophilic addition. The reactant has two functional groups. One is phenol functional group, one is alcohol functional group. When it is treated with the HBr, we know that benzene containing leaving group do not react with HBr, but this HBr react. Since it is a primary benzylic, it follows SN1 mechanism. Therefore here the corresponding product is, first OH we have to remove in the form of H2O. Because of addition of H plus, it forms stable C plus. Now it reacts with the corresponding Br minus, and finally we get corresponding alkyl bromide. Now it is treated with aqueous NaOH, 1 equivalent. When 1 equivalent is added, here we are expecting two types of reactions. One is with this one acid base reaction, and with this one we can expect nucleophilic substitution reaction. But acid base reaction is fast, that's why we are adding only 1 equivalent. Therefore the corresponding product is corresponding phenoxide derivative. We are adding only 1 equivalent. Acid base reaction takes place fastly. Now it reacts with CH3OTS. We know that OTS is a good leaving group and O minus is nucleophile. Therefore nucleophile attack, leaving group will leave, SN2 reaction takes place, and corresponding ether will be formed. It is simply Williamson ether synthesis. The first reaction is nucleophilic substitution, SN1 reaction, and the second reaction is Williamson ether synthesis, SN2 reaction. Here SN2, here acid base. The reactant has ether functional group. Now the ether treated with HBr, and we are using HBr excess. So here what happens, lone pair attract the proton and corresponding oxonium ion will form. Now we know that Br minus will attack, but Br minus cannot attack at this carbon because benzene connected to leaving group reaction won't take place. But at this point reaction takes place. Since it is primary, we are following SN2 reaction. Therefore corresponding SN2 product is like this. It is corresponding SN2 product. Now it is treated with 1 equivalent aqueous NaOH. 1 equivalent aqueous NaOH. So here phenol is acidic. 1 equivalent aqueous NaOH base. Therefore acid base reaction takes place and corresponding phenoxide will form. Now if I observe this reactant, it is a nucleophilic part or basic part, and here we are having primary carbon. Since phenol is more acidic than water, if any compound more acidic than water, the corresponding conjugate base is nucleophile. Therefore nucleophile attack internally and leaving group will leave. Therefore it is a intra-Williamson ether synthesis. The product is ether. So this is also intra-Williamson ether synthesis. The first reaction, nucleophilic substitution. Second reaction, acid base reaction, and followed by intra-SN2. Alcohol treated with SOCl2. It is a secondary alcohol, and secondary alcohol treated with SOCl2. We know that when alcohol treated with SOCl2, it follows SNI mechanism, and SNI involves retention in configuration. Therefore here OH is right side, and we get the final product OHCl is right side. So it is a retention in configuration. Now it is treated with KCN in polar aprotic solvent dimethyl sulfoxide, and Cn minus is ambidentate nucleophile, and it is a strong nucleophile. Since it is a secondary, we follow SN2 reaction. Therefore Cn minus attack from the backside with respect to leaving group. Therefore the corresponding product is PH, CH3, and here cyanide group and hydrogen inversion. Of course we know that since it is an ambidentate nucleophile, nitrogen also can attack from the backside, and it gives corresponding isocyanide. So cyanide and isocyanide. So this reaction is SN2. Therefore it involves finally Walden inversion. That means with respect to leaving group, the nucleophile attack from the backside. So first one is SNI, second one is SN2. Alcohol treated with sodium. When alcohol treated with the sodium metal, it loses proton in the form of H2. Now it is a alkoxide. Now if I observe the stereochemistry of chiral center, here it is observed that retention in configuration, stereo not changed. Now it is treated with CH3 CH2 Br, alkyl bromide. So here two types of reaction possible, because alkoxide can act as strong nucleophile and strong base. When it is strong nucleophile, SN2, when it is strong base, E2. Therefore here suppose SN2 reaction takes place, the corresponding product is like this. So it is a SN2 related product. Suppose if O minus remove the proton from the beta carbon and it gives corresponding product alcohol plus CH2 double bond CH2, and it is a E2 example. It is a E2 example. Now here in SN2 this carbon stereo not changed. Therefore, with respect to this carbon, it is again retention. Generally SN2 రియాక్షన్లో ఇన్వర్షన్ మాట్లాడతాం, కానీ ఇక్కడ రిటెన్షన్. ఎందుకంటే ఇన్వర్షన్ మాట్లాడేది ఎప్పుడు కూడా ఏ కార్బన్ దగ్గర రియాక్షన్ జరిగిందో ఆ కార్బన్ దగ్గరే మనం మాట్లాడాలి. సో ఎట్ దిస్ కార్బన్ నో డౌట్ ఇన్వర్షన్, బట్ ఎట్ దిస్ కార్బన్ స్టీరియో నాట్ చేంజ్డ్. If chiral center is present, we should talk about only chiral center. That's why here the best answer is retention in configuration, because it is a chiral center. Here the corresponding cycloalkene treated with the Bayer's reagent called alkaline KMnO4. It is known as Bayer's reagent. We know that when alkene react with the Bayer's reagent, this reaction is syn hydroxylation. Above the plane OH groups plus below the plane OH groups. So the overall reaction is syn hydroxylation. Now it is treated with the oxidizing agent PDC, pyridinium dichromate. So here we know that tertiary alcohol do not undergo oxidation, but secondary alcohol undergo oxidation. So because of this compound, because of oxidation, we get corresponding product like this, secondary alcohol oxidation. Now this product will be oxidized to corresponding ketone. So this is our final product. So here first one is syn hydroxylation, oxidation, second one also oxidation.